Hey guys, quiet please. Let's get started. So this should be pretty quick. We have 75-minute periods today. Actually, we're about 8 minutes in, so a little delay. But don't think I would take too long. The notes is actually only, I think, 2 pages. So pretty short. It's an extension of logs. It's actually log properties. So it should be reviewed from last year in Algebra 2. The first thing I want to do is just go over the homework. Make sure you guys are comfortable with the homework. And actually, these are the notes. So I opened up the wrong file. Should be this one right here. Here we go. Actually, wouldn't hurt to look at the notes because I wasn't here on Friday. Just remember properties of exponents. And the video makes sense. Was that fine? Okay, it's pretty short. Yes, make sure you know your properties of exponents and apply those properties. The properties can be applied when the bases are the same between multiple powers or among multiple powers. But if you have sometimes you might have like different bases, so you have to change one of the bases, but I think that was in the homework actually. We saw that. So I'll go over that in just a bit. Logarithms. Logarithms is the inverse of an exponential function. Why we have logs? Because if you want to isolate the exponent, you rewrite the equation as a log equation to isolate the exponent. Or like for part A of number 9 or part B or C, you could deliberately set each log expression equal to a variable and then say, well, 2 to the x equals 128 or 16 to the x equals 2 or 3 to the x equals 1 over 27. You kind of solve in each case. Natural logarithm is another type of logarithm we work with. The base is e. E is some like funky number. It's 2.718. It's just discovered by some old-time mathematician like 200-300 years ago, Leonard Euler. He discovered that e to the 1 power, or that this situation converges to a certain number, which he called e after himself. If x approaches infinity, you have 1 plus 1 over x raised to the x power. That apparently converges some number, which is e. E is often used in modeling. In this case, we'll just the growth model. The homework was application of the properties of exponents and other things with logs. So like if you have 5 to the cube or 25 squared, change 25 to 5 squared, right? That makes it a little easier to combine the exponents. Or change 9 to 3 squared and then use properties of exponents. For 3, change both 8 and 4 to powers of 2. Or for number 4, change 32 to a power of 2. Graphing is super easy. The domain's all real numbers for exponential functions. The range will be limited based upon, I don't want to say the vertical shift, but yeah, if the graph does shift vertically, that will impact the range. This didn't shift vertically, so it gets close to 0, but not exactly 0. It's always decreasing if it's decay, always increasing if it's growth. Keep that in mind. And behavior, just looking at what y does when x goes towards negative infinity or positive infinity. In one case, y does go towards positive infinity, but in another case, it goes towards 0. This one here, parent functions, just assume that all the other stuff's not there. So 2dx or 4dx, and what the transformations are. Here you have a word problem, work it out. Log problems. Any questions on this you guys want to ask about on the homework? It's basically just an extension of notes, right? And I gave you guys a key.
The old classwork.
This one right here? The homework? I said the notes. That's just plugging 8 straight up. Yeah, that's all. Yeah, obviously you have to use calculator for some of these problems. Like number 17, you have to use calculator. Rewriting, just make sure you're comfortable with that because we're going to talk more about logs in just a moment. So, Liam, you're good? Okay, cool. All right, let's do notes. So again, the relation between a logarithmic and exponential function is that. So log base b of a equals c equals b to c equals is the same thing as b to c equals a. So this is your input. Now that's your output, right? And this was the output. Now that's the input. That's why the inverses of each other. Okay, very important. So that's the relation between log and exponential functions. So now, properties. If you have log base b of x plus log base b of y, do you guys know what to do? What happens? What do you do with the x and y to condense it? Exactly. Thank you, Kyle. Yes, 100% correct. You can also do the same thing with ln, but I'll do that in just a sec. If you divide, it looks like this. And then power property looks like this. So natural log, you do the same thing. Does that make sense? So this should all be reviewed from last year. Okay. So why do we have these? Because sometimes we have to solve the log equation at multiple logs, so it helps to condense it, and then you can solve the equation afterwards. You might even need this in calculus. You see multiple logs. In order to condense it, makes the problem simple to work with. So that's why we have it. Sometimes we expand, but really more we'd like to condense. I see the next example is about expanding, fine, but condensing is going to be more prevalent or more practical. But yeah, they kind of come from the properties of exponents. I don't need to kind of go over it necessarily. There's kind of a derivation of why these work the way they do, but just know the properties and we'll move on. So the first four examples are all about expansion. Oh, sorry, first six. And then the next four are all about condensing, and that's it. And then the homework looks like it's just going to be some old stuff and a lot of condensing and expanding. So, and I put the answer keys up right in school, just so they're all there. So let's do the notes. Here we go. So expanding just means this. Does that make sense what I'm doing? Right? Why do I put a plus there? What was going on between 7 and x squared? Yeah, so you got to do that. And then am I done? Or is one more thing I have to do? Yeah, I got to move that 2 to the front. Exactly. Exactly. All right, let's keep going. So log base 3 x plus log base 3 y minus log base 3 z. We're good? Why put the minus? Exactly. ln 8 minus 2 ln e. And by the way, ln e is just 1. Because if you think about it, that's log base e of e. That has to equal 1. Right? So that's sometimes a good idea to do. Questions on that one? I'll stop a little bit and then fast. So again, when you see division, you subtract, right? Yeah. ln 8 minus ln e squared. But can I skip this step? Because I moved the 2 simultaneously after 10 minus. That's fine. You want to do that, totally fine. And then you guys see why that's 1? Right? Because whenever the base and the number that's inside the parentheses or the input are the same, e to the 1 equals e. So if that was like 2.58, 2.58, everyone feels it was like 44.67, 44.67, it's still 1 because 44.67 raised to the 1 power is 44.67. So that's what's happening with that one. And then finally for this one here, log base 2 of 4, I'll move the 2 to the front, plus 4 times log base 2 of 3. What's log base 2 of 4? 2 to what power gets you 4, guys? Right. And there you go. All right, we good? Okay, why don't you guys try these next two? I'll go ahead and freeze the screen. And I'll unfreeze in about a minute. I'm gonna try those two really quickly. Hopefully you guys got that. Very important. You know how to change radical form to exponent form. Hope you guys remember square root is 1 now. Okay. Got, well, now you know. Or 4 through is 1/4. So you move those to the front because those are exponents. That's using the power property of logs. And of course, the x cubed is going to multiply the root of y, so you put a plus in between them, right? That makes sense. For here, why do I put 2 minuses? 4 y squared, the entire thing's on the bottom, right? So both of them can become negative. The 49 and the 1. Of course, you lose the front.
Can I do minus plus plus?
That works. Yeah, if you were to do this, actually, I love what you said, Charlie. If you were to do this, that's totally fine. Same thing. Totally up to you. Because you are minusing 49y squared, then you can break that apart as a plus, but you have to have them in parentheses. So that's expansion, and it's just good to know that because that's how we utilize that property. Now, the next 4 are condensing, and that's actually more important because that's what we need for solving equations. So this is pretty simple. Log base 2 of 24. This is also pretty simple. Log base b, I'll do a giant bracket. Now, which of these logs is positive? The first, second, or third? So you do x to the 7th power. Which one are negative? The second, third? Well, obviously second and third. And there you go. And, we probably should change the 5 squared to 25. So we're good? Yeah, cool. All right, 2 more and we're done. Told you, it's very quick today. Move the 2 to the back. Move the 8 to the back. You have a minus and a plus, so you can do, and that's by the way, if you don't see a base, what do you assume the base is? Yeah, exactly, it's common log. But I'm not gonna write it. But if you have to evaluate it, it's good to know. So it's x plus 7 squared, x plus 2, and then x squared. And then here, natural log of x minus 4 raised to the 8th power and y. By the way, I think I could factor this one a bit further. How's the bottom factor? Yeah, so it's x plus 7. Yeah, so if you wanted, you could do that too. I don't think we specify the simplify in instructions. Didn't say so, but it's usually a good idea. So keep it simple, right? Homework, if you guys want to get a head start. If you have some other stuff to do, that's totally fine. We still got another 52 minutes. Given that the weather's nice, do you guys want to have the rest of the class outside? Yeah, is it no objection? Yeah. Okay. So all I ask is you guys just don't wander. We'll just meet kind of like in the little grassy area by Campbell and Homer, and I know some of the seniors want to hang out in the senior pad area. You can. You can use it work at homework, other stuff. So I'm gonna pack my stuff too. Plus, I selfishly want to get lunch early. Anyway. All right. So yeah. So just stay like in the middle area.
Thank you.